Greetings viewers, in this video we'll go through Cambridge A-Level Further Maths Syllabus Code 9231 Component 1 Further Pure 1. This is variant 3 from the May June 2025 series. I'm going to attempt question 3 in this video. The previous question has been uploaded into the playlist already. So in question 3, they are giving us a quartic equation with the roots alpha, beta, gamma and delta. First, we want to find the value of the sum of square of the roots. First of all, a bit of recap on the quartic equation roots. So if these are the roots, means the equation, it will look something like this one. Okay, so equals to 0. So meaning that if you expand this, you will get back the same equation, and with that we'll compare the coefficient to try and get to this sum of square. So I'm not going to expand it manually in this video, but I'll just use the result which you would have learned already. If you're interested in doing the expansion yourself, please do try it, because it's may be useful in case you forget about the result of this thing, so you can actually just derive it yourself on the spot. So I will just do the result here. Okay, so this is the full expansion after you extended. Again, I did not write the derivation step. This is just the result. So if you look at it, the coefficient of the x cubed, that is just the sum of the roots. And the coefficient of the x squared term is the multiplication of each of the combination of the roots, right? So you have alpha, beta, and so on and so forth. For the x, okay, the x term, the coefficient is the combination of three of the roots all multiplied together. Last one, the independent of x, that is just all the roots multiplied together. So where we find this alpha, I mean the sum of the square here, we can use the relation that you also would have learned related to these roots, which is the you take all the roots sum together and then you square it. So I'm going to just write the results, but you can try and expand it on your own. Okay, so after I've written this result, so oh my god, you can see more clearly about the resemblance of the coefficient, right? So the x squared coefficient, or the multiplication of two roots, is the same as here, the two roots multiplied together and all the combination of it. So for now, we refer back to the original equation. Which one represent this x squared coefficient? That will be 7 lah. Okay, 7. So this entire term represented by 7. And now we have one more missing information, is this one, the sum of the roots itself, which you can find from here, the x cubed term. So if we look at our equation, the equation given to us in the question, so where is the x cubed term? There is no x cubed term. So meaning this sum of square, that is just 0. Okay, so it's a plus 0 x cubed here. Okay, now we move on. So we already know this is 0. I'll highlight in green. And this sum of square, that is what we want to find. So I'll just leave it as the unknown first. And again, this yellow highlighted one, we have identified that is just 7. I think I make a mistake here. This expansion, this one is supposed to be a positive and not a negative. Okay, so I make a mistake here. Okay, so again, I will highlight this back in yellow so you can refer. And now, okay, this is, we can just isolate back what the question want. So alpha squared, beta squared, gamma squared, delta squared equals to negative 14. And so we have completed the question. Moving on to part B. Now we want to find the sum of power of 4. Okay, so unlike the power of a sum of square or sum of cube, we do not have a formula for this that you have been taught. Yeah, I believe you have not been taught any of the formula with sum of power of 4 one. So how do we find this? We have to go back to the factor theorem you have learned in your high school. You should have learned in your high school, I believe. So it's something like, if, okay, let's say we assign this function px, okay, so that's px, and these are the roots of the equation. So meaning p alpha, by the factor theorem, that will be 0. P beta will be equal to 0, and so on and so forth, right? Each one of these you evaluate at the roots, it will be equal to 0, because that is one of the characteristic of the factor theorem. So what we're going to do is we are going to use that fact. So we are going to add all of this up. We evaluate at each of the roots, and since again we have, by the factor theorem, each one of these terms will be equal to 0, so the whole thing summed together will still be equal to 0, right? And since uh, these are all okay, all the x will be replaced by alpha, gamma, beta, and delta. So I'm just going to do that first. So once you evaluate at each of these roots, you can kind of collect the terms. And you collect all the power of 4, all the power of 2, all the power of 1, and the constant term, which you will just get 88. So actually there's a more shortcut way of doing this once you understand the concept, is that you can assign each of these parameter by just summing the roots. If it's a power 4, so you sum the roots, I equals to 1 to 4 of these 4 roots. So alpha, beta, gamma, and delta. And the same as here, so sum of the root, square it. Okay, you sum the 4 roots, and then sum the roots again. This is power 1 only, so sum 1 to 4, and last one will be just 4 times of, or actually if you want to write it properly, is a sum of the root power 0, so 1 to 4, something like that. Okay, then equal to 0. So this one is the more shortcut way of doing it, which I believe you may have been taught this way also, but this is the explanation behind why you can just do that. So again, if you look at the values here, this sum of roots we have already determined before, that is equal to 0, right? Because there is no cube and no x cube coefficient, and this sum of the root square, we have just found in the previous question to be negative 14. So we will again use this result. We will just use the result, and we will isolate the sum of the power of 4. So again, 7 times of the sum of square, that is 0, right? 0. Yeah, highlight in blue. Sorry, sum of square is not 0. Sum of square is 14. Negative 14. And 3, sum of cube. Sum of the roots, that is 0. That's the 0. And 88. And so you have to just isolate the parameter that we want to find, and you should be able to get 10. Okay, so that's part B. So to find the sum of the power of 4 of the roots. For part C, we want to use the standard result of the list of formula MF19 to find the value of this sum. So sum of the roots, the root squared plus r, and square it. So first thing, maybe we can try and expand this first. So this is just a quadratic expansion. You should be quite familiar with this by now. Okay, so after you have expanded all the terms, and we have collected again, once we collect all the constant term, the r term, and the r squared term, if we look at this two coefficient, the independent coefficient and the one with r, something similar come out. Okay, the again, the sum of square we have found it. right? Previous question, if we have found it, I'll highlight in blue. And then also the sum of the power of 4. We have found it in this question. So highlight in pink. So again, we can just substitute the value and we can use, then from there we can try and simplify further. So this is 10, this is negative 14, so negative 28 for r squared. And this one, okay, it's just simple by substituting the formula. We come to the formula sheet, MF19. Okay, sum of r squared from 1 to n is this one. Sum of r 1 to n is this one. Just use the formula sheet. Okay, what about sum of a constant? Just a constant. Okay, it does not give in the formula sheet, but by common sense, you know that if you keep summing the same thing over and over again for 10 times, okay, this should be 1 to 10. Okay, we sum from 1 to 10, you will just multiply by 10. Okay, that's just by common sense lah. So we have 100, and the 28 sum of r from 1 to 10, get half of 10 and 10 plus 1. What about r squared? R squared is 1 over 6, 10, 10 plus 1, and then 20 plus 1. Okay, I hope that's the formula. Okay, correct. So if you type this into your calculator, you should be able to get just 100. So that is the final answer for part C. Okay. So I believe this type of question is not difficult. It's just about if you remember the identity or if you can derive the identity on the spot within the time frame that they given you. So it's not difficult, you just have to apply it. And you cannot make the careless mistake in one sign or one symbol wrong, and then the whole question will be wrong. So thank you for watching the video and all the best.